Hello Year 9s and welcome back to Math and Magic. In today's lesson we're continuing our topic of indices and surds, and we're going to be looking at our next set of index laws. Now we've been looking at a whole bunch of index laws. What we're going to be looking at today is looking at what happens when our index or our power is a fraction. So our learning intention today is to understand and apply index laws, and we want to be able to identify the index laws for fractions and simplify expressions involving indices with fractions and evaluate numbers with fractional indices. So let's get started with today's lesson. Now, this is the fractional index law and surds. So a fractional indice can be written using a square root sign. And so here, if you ever see a fractional index, so 1 over a to the power 1 over m, or 1 over any number, the way that we write this is, this becomes the mth root of a. The mth root of a. So that's what the fractional index law is. Now you might be wondering, what the heck is the mth root of a? Well, the mth root of a, I'm going to write this on the side here. The way this works is that if the mth root of a is just a number where if I took m root a times m root a, and I repeated this a few times, in particular, if I repeated this, let me just copy this again because I can't be bothered writing it again. Nope. Couldn't do it. Here we go. And I hope it's this one. There we go. And I put in another one. And I repeated this multiplication and I did it m times. I did this m times. M times. What would happen is this would result in the letter A again. And you might have actually seen this before. You might have seen this when you looked at square roots. So for example, if you had square root of a number times another square root of a number, which is exactly the same, well, this results in 3. Because the square root is actually a fractional index of, and it's hidden, 2. So if you ever see a square root just by itself, it has a hidden fractional index of 2. And so when you see a square root of a number times by itself, another square root of a number, but it's the same square root number, that just is 2 times of the same square root, and this just results in the number inside our root. And so here, whenever you see a fractional index, it just means that we take the mth root, or that particular number in the denominator of that root. And so here we actually get introduced to a new word. A surd. Now, a surd is an irrational number written with a root sign. For example, square root 2. Now, here we've got a few words that we need to talk about. Irrational number. An irrational number just means a number which cannot be written as a fraction. So for example, there's a lot of numbers that you can write as fractions. A half is a fraction, which is great. You can also write whole numbers as a fraction, and I think I showed you guys this when we looked at negative indices. If I said if I had the number 2, I can actually write this as 2 over 1. Any whole number we can write as a fraction. But there's a few numbers that we can't write as fraction. For example, pi. Pi is an irrational number. We can't write it as a fraction, even though a few people have approximated pi, and so you might have seen that some people have said that pi is approximately 22 over 7. That's great, and it helps us get to like some digits of pi, but it doesn't help us get the full figure of what pi is. Pi is an example of an irrational number. And in particular, what happens with irrational numbers is that when you put this into a calculator, the calculator actually will calculate a number that keeps going on and on and on and on and on and on and on forever and ever and ever. The digits don't actually end. So here, I've got this example, square root 2. So for example, if I put in square root 2 in my calculator, I get this number, 1.414213,562. And what would actually happen is, let me try that again. ... These digits would go on and on and on and on and on forever. It doesn't stop. That's what an irrational number is. An irrational number is a number which cannot be written as a fraction. when we put this in a calculator actually stops after a certain number of digits. So here, my calculator stops at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After the 10th digit, it stops showing this. But if you went online and went to search for square root 2, the exact value of square root 2, you could see that these digits keep going on and 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 forever. So a surd is what happens when we have an irrational number and we write it using a square root. And so there's other surds. So for example, you could get square root 3, which is square root 3. Ooh, let me try this again. Square root 3, which is equal to 1.73, 1.732, and on and on and on and on and forever. And so here, whenever you see an surd, is basically a type of number where we can write it with a square root. And often when we deal with these fractional indices, it's going to result in these surds. Because if you have a look, the mth, when we take the fractional index, that just means I take that mth root. And so it's going to involve that root sign. Okay, so I hope that wasn't too confusing. But what we're going to do is we're going to actually apply this fractional index rule. So writing numbers with fractional indices. So the denominator of the power is the root that you're going to take. So the quick way of remembering this is the denominator, so the number at the bottom of the fraction in our power, denominator of the power is the number root that you're going to take. So here we've got two examples. Write the following numbers using a square root sign. So here I've got the first example, 6 to the power a half. So what I'm going to do is I'm going to look for the number at the bottom of my fraction. So here, the number of the bottom of my fraction is a 2 in my denominator. So here, 6 to the power a half is just going to be the second root of 6, second root of 6, or 2 root 6. Now, here is a special case. If you ever have 2 being this number, the root, we don't actually write 2. So just like in algebra, when we write, when you see 1x, for example, we don't write that 1x, we just write it as an x. Similarly, when we deal with surds, if you have the second root is just the square root. And so we don't actually bother writing this 2. So here, the final answer is actually just going to be square root 6. Okay. So that's what we're going to do. We're going to look at the denominator. It's going to tell me what root I need to take. And then I'm just going to put that outside my square root and then write the number that's left over inside. So here for this second example, I've got 2 to the power of 5th. So here, this just becomes, well, the number in the bottom of my denominator is 5. And so this just becomes the 5th root of 2. Okay. Let's just do one more just to check that we're all on the same page. So here, the last one I'm going to do is the third root, 3 to the power 1 over 4. 3 to the power 1 over 4 just becomes, well, the denominator is just 4. And so that just becomes the 4th root of 3. So there we go. When we're using fractional indices, all we do is we look at the denominator of that power. So here in the first one, it was 2. The second one, it was 5. And the third one, it was 4, and we just take that root on, we write that root on the outside. So here I have the second root of 6, the 5th root of 2, the 4th root of 3. And the special case is when we have 2. So if you ever see a second root of a number, we just write that as a square root, and so we don't worry about writing that number outside. Okay, so that's it for this writing the fractional indices. Okay. Now, the second thing that we can do is we can actually evaluate a few numbers with fractional indices. Now, this is particularly the case when we get given numbers. Now, what I have here is not all fractional indices will result in surds. So a surd, what we said earlier, was a number that we write with a square root and it keeps going on and on and on and on and on and on and on forever. So I've got two examples here. I'm going to actually use these to show you special cases. So here I've got the square root of 9. Now, if I look for the square root of 9, so square root 9, that actually gives me 3. And so this is an example that isn't surd because we can actually simplify square root 9. If you think about it, so what I said was this square root number is if I times it, I need to think of a number where if I times it twice would give me, or 2 times on itself would give me 9. And so if you do 3 times 3, so 2 lots of 3s multiplying together, that actually gives me 9. And so here, if I follow that same pattern, I'm looking for a number where if I raise it to the power 3, or I times it, that number times itself by times itself, so to the power 3, it would give me 8. Well, I can actually figure this out. This becomes, I believe, 2. So if I chuck this in my calculator, there's a little nifty button here, shift this guy. Nope, not that one. shift this one, I can put the third root of 8, and that gives me 2. And so if you think about it, if I do 2 times 2 times 2, well, 2 times 2 gives me 4. 4 times 2 gives me 8. And so that's a third root of 8. So not all surds will result in, not all fractional indices will result in surds. Sometimes we can actually simplify it and it gives me a number. So here, evaluating numbers with fractional indices. Let's have a go at these following examples. So what we're going to do is let's just write these numbers using our square root, not our square root, our root notation. So the surd stuff that we looked at up here, and then let's see if we can actually evaluate them. So let's have a look at these examples. Evaluate the following. The first one, 144 to the power of a half. So what we did before was we take the power, we take the denominator of the power, so that's 2, and so here this is going to become the second root of 144, or the way that we write this is just the root of 144, and so we read this as square root 144. Now, is there any number where if I times it by itself, so 2 lots of them, if I multiply this number by itself, it'd give me 144? Well, if you think of it times tables, 144 is actually just 12 times 12. There's 2 lots of 12 there. And so here, this just becomes 12. And we can check this with our calculator. Square root 144. Square root 144 actually gives me 12. And so here, this is another case where it doesn't actually end up in a surd. Let's have a look at the next example. I've got 27 to the power a third. So here, once again, we get the denominator of the power, so 3, and we just write that outside the root. So this is the third root of 27, or we also read this as the cube root. So the first one, if it's 2, it's square root of a particular number. If it's the third one, it's a cube root. And so here we're looking for a number, if I multiplied it on itself 3 times, so that number times itself would give me 27. Okay. Now, I can actually do this in my head fairly quickly because I've done this a few times, but 3 times 3 times 3 actually gives me 27. So 3 times 3 gives me 9, and then 9 times 3 gives me 27. So this answer is going to give me 3. If you're not sure how to do this, you can always grab out your calculator and just go, okay, I want the cube root of 27, and that should give me 3. So there we go. So here, sometimes when you get given a number with the fractional index or indice, you can actually evaluate it, particularly when you notice that it's a cubed number or a square number. So those are the ones that we want to look out for in particular. Okay, so here we were able to actually evaluate a few numbers using our fractional index. Now, the final thing we want to do is actually combine some of the index laws that we've looked at so far. So what we can do is we can actually simplify algebraic expressions using our index laws that we've looked at so far. So if you remember, a few index laws, we're actually going to have a look at a few examples of index laws that we looked at so far and actually apply it using our fractional index. So, example 3, use index laws to simplify the following expressions. So let's have a look at the first one. Here we've got a to the power of a half times a to the power of 3 over 2. Now, if you remember, when we multiply indices together, what do we do with their powers? Well, when we multiply indices together, we actually add the powers together. So here, this is just going to become a to the power of a half plus 3 over 2. So that's what we're going to have in the power. So a to the power half times a to the power 3 over 2 just becomes a to the power a half plus a to the power of 3 over 2. And so here we can simplify this. Now, but when we add fractions, we need to make sure that the denominator is the same. So we both have a denominator of 2, which is great. And then we can just add the numerators. So here this just becomes a to the power 4 over 2. Now, 4 over 2, that's actually a number we can figure out. 4 over 2 is just 4 divided by 2, or just a squared to finish it off. Okay, so we can apply our index laws of multiplication to just add our powers together, and from there we can actually simplify and make our fraction a little bit easier to read. Our indice a little bit easier to read. Okay, let's have a look at the next one. Now the next one, we have x to the power of a half over x to the power of a third. Now, whenever you see an over, this actually tells you need to do the operation of division. And so we've looked at an index law for when we divide indices. When we divide indices, what we need to do is we need to subtract the power. So here we're going to have x to the power of a half minus x to the power of a third, or x minus a third. Okay, And so when you see division, that just means you're minusing the powers together. Okay. Now here for this one, notice the denominators are not the same. So what I'm going to do on the side is I'm just going to do the working out so I can simplify this a half minus a third. And so what we want to do is make a common denominator. We want to find a multiple that both 2 and 3 go into. That happens to be 6. And so I'm going to rewrite these as fractions over 6. So a half as a fraction over 6, it becomes 3 over 6 minus 2 over 6 for a third. And so we're left with 1 over 6. And so the final answer here is going to be x is to the power 1 over 6. And we can write this using our Surd, our fractional power law that we looked at today. So here we have a denominator 6, and so this just becomes the 6th root of x. And so here we applied that index law for division. And so what we could do with division is we minus the powers together. And so here we did a half minus a third, and we noticed that they didn't have the same denominator. So we had to convert them to the same denominator and then subtracted, and we were left with a fractional index, and so we could actually rewrite this as a third and the final step. Okay, now the last example here. See, we've got y to the power 2, so y squared, or to the power a quarter. Now, here we have a power being raised to another power. So notice here we've got this bracket, and so we've got 2 and we're raising it to a power a quarter. So when we see a bracket like this where we're raising a power to a power, what we need to do is we multiply the indices together. And so here this just becomes y to the power 2 times a quarter. So here, when we multiply, this just becomes, okay, well, I multiply that 2 into my fraction here. So this becomes y to the power 2 over 4. And when I simplify that, that becomes y to the power 1 over 2. So here, if you're not sure, we can always go to our calculator. 2 times a quarter becomes a half. Okay. Now the final step here is when I've got this to a power half, that's a fractional index. And so I can rewrite this using my fractional index laws as a surd. And so this becomes the second root of y. And as you remember from earlier in this lesson, we talked about how when you take that second root, we don't actually write the 2 there. Okay, so that's how we can actually combine our index laws that we looked at so far with fractional indices. So that's it for today's lesson. Let's do a quick recap of what we looked at in today's lesson. In today's lesson, we talked about fractional indices. And so when we have a fractional index, we rewrite that as the mth root, or the mth root. And so we use a root sign and we just write whatever number is in the denominator of our fraction outside the frame. That tells me what root we're going to need to take. And this, when we write it like this, these often is going to be called a surd. A surd is a number, an irrational number that we use a root sign to write, and it's a number that cannot be written as a fraction. So what happens is we notice it goes, when we put this in the calculator, it goes on and on and on and on and on and on forever. And so what we did was we rewrote a few numbers using fractional indices. And so the way that we did this, the quickest way to think of this is just finding the denominator in our power and just writing that outside the root of the number that we're taking the index of. And then we also went through and simplified a few numbers that even though we put them in through a fractional index, or took the square root of, or took the cube root of, that didn't actually result in a surd. And so these were a few special numbers that happen to have these properties. And finally, we looked at applying our index laws along with our fractional indices. So the first example, when we multiplied indices, we actually had to add them. The second one, when we divided indices, we subtracted them. And the final one, when we took a power of power, we multiply. So that's it for today's lesson, Year 9. Hopefully that was helpful, and I hope that that was easy to follow along. There's a few concepts there that were a bit confusing potentially. So if you need to go back and have a watch of those sections again, that's totally fine for you to do that. But that's it for today's lesson. I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye.